dig even deeper into Haas. Okay, so a machine that just debuted is the UMC 500. I'm going to go on camera right now and declare that the UMC 500 is the new VF2. I know that's because the VF2 is the biggest seller, right?
Yeah.
VF2 SS, I think, is the hottest seller.
Yeah, between the VF2 and the VF2 SS, I don't know the numbers, but it's got to be half our machine sales.
Okay. My Haas rep at the HFO, she says she sells
a
most
lot
of those. Yeah.
It's a bread and butter.
But the UMC 500, it's set of production. I mean, when there's a shrinking workforce because people aren't coming up to understand machines, to reduce setups, I think, is the key into the future of machine. UMC 500, it's a smaller machine, multi-axis. That's why I think it's the future. Where am I wrong? What am I overlooking?
For the higher volume, you can still go into like an EC400 or something like that. We have the horizontal, or maybe you'll get a larger machine for, obviously, if you have larger parts, then you need a larger machine. If you're running the exact same part over and over and over again, it might make more sense to fill a table and let this thing run all night long. So the next morning you come back in and you've got 50 parts done, which might benefit you. But like you're saying, if the part has a lot of faces on it, a lot of different operations, you can sure save a lot of time, and especially now you just put an operator in front of it or a robot and hit all those operations in one shot. And they're really not that hard to program, especially if you're not doing simultaneous swarf cut, which honestly, how many of us do that? That's got to be the 2%, 5% of what we do. The 95% of the parts that we make, if they've been well designed, right, you're trying to keep the cost out of the part, so why would you add a bunch of needless simultaneous motions unless you need it? If you can run that part on your VF, then to transfer it over onto a UMC 500, it's one extra line of code, and now when this thing flips over, you can just patch together all your regular codes from the vertical, and then it just runs. It's not rocket science. The simultaneous and getting that right, roughing that's rocket science.
So my question, because the UMC 500 is the next machine I'm going to buy.
It's awesome. I think it's going to change the industry.
Okay.
And I work at Haas, and so there are certain machines where I'm like, okay, that's good for this task or that task. The layout, when you see the 500, the UMC 500 naked without its sheet metal, you look at it, you're like, that's a stout machine. That's going to cut really well, right? And then when we did test cuts on it, you're like, this thing cuts really well.
Yeah.
It's just another iteration of everything that we've done prior to this. So we redesigned the UMC 750. All those lessons learned were made, everything was made better in the UMC 500. Now we're actually, the UMC 500 is a copy of the 750 with a bunch of changes. And now we're making a copy of the 500 and making a new 750.
Okay.
It's a funny back and forth.
Which was in development first, the UMC 1000 or the 500? Because the 1000,
It was a 1000.
That was larger, IMTS,
but
that's right.
It was almost at the same time. So we had a lot of engineers working on it, Eric Wood and others, who were designing that. And so everything that they were doing for the 1000 to make it better, even at that time, it was just weeks or months later that they knew they were going to hit the 500. So they might as well have been done at the same time.
Right. Okay, that makes sense.
Yeah.
Okay. Yeah. And so the thing that's new to Haas is the HSK spindles.
Yeah.
And that's
there's
on the
still
UMCs.
a lot of those things.
Are they okay?
And I didn't expect that because that's a very pricey spindle.
Right.
And for good reasons. There are a ton of moving parts in an HSK spindle. The little clamping fingers and this type of thing. It's a much more complex system. But it is more rigid than a Cat 40. But it's like anything. If your tool's not chattering, making everything more rigid doesn't do anything for you, right? If you're already at speed and you're already making parts, and what are you gaining? So there's this line where people might need to stick a tool out further, or run higher RPMs, or the spindle needs to compensate. Let's say on a UMC 1000, a stouter spindle might have to compensate for this crazy, stupid, ridiculous 5-axis workholding that you have, where no one thinks that's right. No one in their right mind thinks you should hold a part at the end of a yardstick and try and machine it. That's ridiculous. But there's nothing you can do about it. You have to be able to reach all sides. You have to mount it on this stupid stack up. But sometimes by going with, let's say, that HSK 63 spindle and making that just a little bit more stout, as a system, you're compensating for that terrible work holding that we're forced to go with, and you can get away with it.
Right.
And so people are doing that. They're buying those spindles. I don't know how much they cost. I'm not a sales guy. I'm guessing 20 grand more, so I don't know. They are a little bit more maintenance. I know, so I ran a lot of mill turns for a number of years, HSK, and you got to watch out for it. It's not like the Cat 40 where maybe once in a blue moon you'll throw some grease on a pull stud, right? Keep the little balls that grab the pull stud lubed, and it's not even that critical, right, for the Cat 40. But on the HSK, totally critical. So you'll run the same type of drawbar pressure gauge on HSK, and if those fingers that are grabbing they go from the inside out on the HSK, if those aren't greased like all the time, like once a week or once a month, you'll start losing holding pressure.
Wow.
And so you got to think about that.
Right.
There are tools out there. Rome makes a Lubra tool that actually goes in like a tool in the spindle and just greases everything for you.
Wow.
And they have sprays and grease. A little bit more work there that you have to think about. But
Yeah, I had
it's
no
a really
idea.
effective system.
That's a really good unintentional Haas tip of the day.
It's
there. I had no idea.
I don't want to say this.
We
I
can cut it.
ran this machine, right? $1.7 million machine for a year and a half. Before, this is the same thing.
Because no one told you?
No, I had no idea. And literally, I'm calling up this manufacturer saying, I've got some chatter and stuff like that. I'm like, what else should I know? And they're like, well, you're already doing everything right. I don't know why. I mean, you're greasing the spindle and you're jamming the arch. I'm like, oh yeah, I'm doing that. And I got off the phone and I'm like, holy cow. Wow. I ran this machine for a year and a half, and my tool clamping force was clearly dropping.
Wow.
In the same way that on a lathe, you need to grease that chuck, right?
Right,
And there's nothing wrong with your chuck. It simply needs to be greased like every day, week, month, whatever. Often.
Okay.
It needs to be greased pretty often. And if we put in a pressure gauge, we can actually see the reduction in clamping pressure on your lathe parts if you're not greasing that chuck all the time. We'll come into a shop and they've never greased it because for whatever reason they're like they just don't. So it's very much like a lathe chuck in that the HSK spindles need to be greased pretty often.
Yeah, that's not too bad. So I had a Haas TM3P.
Yeah.
Very entry-level budget machine. Worked great, loved it, made a ton of money from
So
it.
the manual grease?
It was manual grease. Yeah.
People don't know.
It was just part of the thing. And there's a maintenance tab that we set it to 40 hours. And when it popped up with an alarm, go get the grease gun, 2 pumps here, 2 up top, and
done.
It was just a way of life.
Yeah.
So that's not that bad. I don't want people to get scared that you shouldn't buy an HSK because you have to grease it.
No.
It's just one thing that's good practice.
Yeah.
Yeah. Or
It's
necessary.
high RPM, high balance, adding a grease system to do that automatically is not practical in the location that you'd want to put some little bits of grease. But it's a nice system. Yeah. And again, it's cutting really well.
So for that reason that you would need to have a long reach tool, high rigidity, it probably won't make its way onto the VF series because it's just not.
I think it will. Again, I'm not the guy to ask, but it's going to.
Okay.
I think so. I think it'll be an option. If it's not already, it could be an option today, and I wouldn't know it. But it's certainly going to be an option.
Yeah, that's great.
Because we make the spindles, they eventually make a way for those to cross over.
Well, I think of it, so maybe it's not needed on a VF, but I've got all this HSK tooling or...
Yeah, maybe.
Here's what I don't know about HSK. Is it dependent, like you have to get different pull studs for Cat 40 depending on the machine brand. Is HSK universal?
No, there's different brands of machines that they're actually more universal than, let's say, a Cat 40. Every brand of machine practically takes a different angle on the pull stud. You'll get into trouble with that. The HSK, we've got a 5-axis GM2 5-axis, crazy, and it spins around. And that's HSK 63, but it's actually HSK 63F, I think. It's got no drive dogs on there, and they do that for balance. It's just it keeps everything with the system more balanced and smaller, more compact for these knucklehead machine type things. And then our regular UMCs that have the HSK. I think that might be an HSK 63A or D, but it's going to be a different style. Same thing, just doesn't have the drive dogs cut out for it. And so it's not quite the exact same tool, but most machine builders are using 63A.
Okay, all right. Yeah, I got to educate myself on that because I know it's better, has advantages, but it's a whole different thing, you know, to bring into the shop. When we're standardized, we're big on standardization, you know, it's just Haas mills, period.
Yeah,
So,
exactly, and that's
yeah.
tough. Yeah.
Yeah. So let me, we have a Pierson Workholding Q&A series.
Uh-huh.
We're gonna use this time where I'm gonna throw 3 questions at you.
I'm ready.
Okay.
I'm
First question.
I'm gonna make this up.
If you were starting out, maybe you got some experience at a shop and you want to have a product, or say you're having a product and it's made and you want to bring it in-house, you want to start up a little machine shop in your garage. What machine or machines would you buy? What would you recommend?
If it's going to my garage today, I mean, clearly the simplest way to get started is by buying a